Welcome back, America. We're live from Dr. Math Studios here in Hollywood, California. Our phone lines are open at 1 800 Math with Dr. Math. Today we are going to be looking at the square root property on this show. If you have any questions, concerns, or comments, make sure to call us at Math with Dr. Math. Here we go. Show them what's up, Johnny. All right, folks. So welcome back. Let's do a little review here. I'm sure you're all pumped up after that, but let's settle down. All right. So first of all, let's look at this idea of what the heck is a quadratic equation. We've seen this in the past. All right, but I want to tie this back in to what we're doing today. So a quadratic equation, remember, we're looking at standard form, is something where we have something squared plus something times x plus some constant, and we set that equal to 0. That's what we were doing in our previous lessons, right? And so far, the only method we have seen in solving these, so our method to solve such a quadratic so far has only been, we've only seen factoring, right? We factored, and that's how we've been able to solve these. So for example, just in case you have forgotten, let's do a quick little example just to remind ourselves what is going on here. All right, so we had a quadratic, say it looked like this. And what we've done in the past is we factored this using whatever method you want. I taught you the AC method, which meant we multiplied this 1 times this negative 12, and that number went up here. Our middle coefficient, which was a 1, bam, that went right there. And I just realized I forgot to mic myself up, so maybe you might hear a volume change. I'm not sure. My bad. All right, so now we're looking to see which two numbers multiply to give us negative 12 and add up to positive 1. So our two numbers are, good. If you heard the girl in the back, she said positive 4 and negative 3. All right, so we're going to take those factors, all right? So let's grab those mother factors, and we're going to end up with, let's see here, x and x. And then we're going to take this plus 4, we'll stick it right here, and we'll take this minus 3, and we'll stick it right here. So we got the plus 4, and then that's a 4, it's French, and then we got the minus 3. And then we always check to see if I could divide by a GCF. Nothing here, no GCF, so we're good. So now what do we do with these factors? Perfect. Set each of them equal to 0. So I got the x plus 4, I set that equal to 0, x minus 3, set that equal to 0, and so we end up with negative 4, and x equals positive 3. All right, so this is everything we've done in the past. So these are my two solutions here. All right, so how is this going to differ from what we're going to do today? All right, so let me go ahead and show you. Let's look at another example here. So let's do one more, and let's make this comparison. So we'll have two problems here. So one of my problems, let's have it look like this. X squared equals 9. And our other problem, let's have it x squared equals 11. Okay, so based on what we know, we could go ahead and we could subtract 9 from both sides, and we end up with x squared minus 9 equals 0. And on this one, we could go ahead and subtract 11 from both sides, and we end up with x squared minus 11 equals 0. Well, this one's nice because it factors nicely. All right, we're left with x plus 3 and x minus 3. And then on this one, well, we have a problem, right? we can't factor it. All right? So notice, we cannot factor this. And because we cannot factor, so let's put not factorable. So because it's not factorable, we need a new technique. All right, so this new technique, let me go ahead and start a new page here. This new technique is going to be called our square root property. And some of you have seen this before. All right, it's called our square root property. And let me show you what it looks like. Let me start off with the easy example with that first one, x squared equals 9. And my first question to you is, how do I get rid of something that's squared? What's the opposite of squaring something? All right, good. So just as you heard, the opposite of squaring something is taking the square root. So I'm going to take the square root of x squared. Because notice, when you take the square root of x squared, the squared and the square root, they cancel. But whatever you do to one side, you got to do the same exact thing to the other side. But whenever you take the square root, notice you're going to get two answers. You're always going to get a plus and a minus. All right? So we're left with x equaling, what's the square root of 9? Bam. Plus and minus 3. So we end up with these two answers, a positive and negative 3. All right, so let's use that same idea and let's use it to solve this problem right here that we couldn't solve earlier with factoring. All right, so looking at this right here, notice I have an x squared term all by itself. So this guy is isolated. Whatever is being squared is all by itself. So just like we did before, to get rid of whatever is being squared, we take the square root of both sides. All right, we take the square root of both sides. But just remember, you're going to end up with the plus and minus answer. So we take the square root of x squared, and we're going to take the square root of 11. And because we don't have a nice square root of 11, we're just going to leave our answers as one is negative square root of 11, and our other answer being positive square root of 11. All right, so those are two solutions right there. Okay, so what happens as these problems get a little bit more involved? All right, so let's take a look here. What happens when the problems get a little bit more involved? So let's look at 5x squared equals 15. So go ahead and write this in your notes. We always want whatever is being squared. Again, whatever is being squared, you want that isolated. So you want x squared all by itself. So with that said, we're going to go ahead and have to divide by 5 first. All right, because our goal is to get whatever is being squared by itself. And now you have x squared equals 3. And now to get rid of the x squared, right, how do I get rid of something being squared? Boom. All we do is take the square root. And just like we said previously, whenever I take the square root, you need a positive and negative solution. So our two answers, we have x equals negative square root of 3 and positive square root of 3. All right. So hopefully that's making some sense there. All right. So another question that might arise, let me go ahead and shrink this down. Move it off to the side is, hey, what was all that stuff we were doing the other day with imaginary numbers? All right, so let me show you how that's going to help us today. All right, so let's go ahead and copy down this problem right here. So let's go with 4x squared plus 9. Let's set that equal to 0. Okay, so again, our goal is to solve for this x squared. We want to isolate it first. All right, so let's go ahead and let's subtract 9. So we'll subtract 9 from both sides, and you end up with 4x squared equals negative 9. And then now we see we're going to have to divide both sides by 4. Divide both sides by 4. And so you're left with x squared equaling -9 divided by 4. Well, how do we get rid of something that's being squared? Good. We take the square root of that. So we're going to take the square root of both sides. So let me go ahead and do that here. I'm going to take the square root of this side, and I'm going to take the square root of this side. But whenever I take the square root, again, we're left with the plus and minus. So we're left with, let me go ahead and write this higher for us. We're left with x equals a negative, and let's go ahead. What's the square root of -9? Well, we saw yesterday that that's 3i. And what's the square root of this 4? Well, that's just 2. So let me repeat that. So we're looking right here at the square root of -9. So whenever you have a negative and you're taking a square root, that's where that I comes from, just as we've discussed before. And we know the square root of 9, that's just 3. All right, so the reason this was negative is because I was looking at the negative piece of the answer. But now I'm going to go ahead and look at the positive piece of the answer. So that's one of our solutions. And the other solution is positive 3i divided by 2. And you're always going to get a plus and a minus because we're taking the square root, and you end up with those two solutions, a plus and a minus. All right. Any questions there? No? All right. So let's do one more before you take a look at some problems and try them on your own. All right. So let's go with x minus 2 squared equals 7. All right. So we notice we have something being squared. So what's the opposite? All right, how do I get rid of this square right here? All right, so hopefully you heard that from the guy in the back. He said take the square root of both sides. So let's go ahead and we're going to take the square root of both sides. Let me make a mistake. What mistake did I just make? Good. I forgot the plus and the minus. So we're left on the left-hand side with x minus 2. And on our right-hand side, we have two solutions, right? We have a positive and negative square root of 7. All right. This is the very first time where on the left-hand side, you're left with an expression over here. It's not just one number or letter. All right. So what we're going to do is we are going to set two equations. All right. One equation is going to have a negative square root of 7, and the other equation is going to have a positive square root of 7. All right, so make a note of that. We have two equations. One's going to be positive, one's going to be negative. And now we just solve each one. So let me go ahead and add 2 over here, add 2 over here. So we're left with x equals 2 minus the square root of 7. So there's my solution for that one. And over here, let me go ahead and add 2 and add 2. And I'm left with x equals positive 2 plus square root of 7. So there's one of my solutions, and there's my other solution. All right, so notice, once whatever is being squared is by itself, that's when you go ahead and you take the square root of both sides. You can't take the square root unless whatever is being squared is all by itself. All right, so let me give you some practice, and we'll see how things go here.